I would like to give you a short review about two TNA access we have already conducted. Just a short repeat of our infrastructure which is established at our university in a couple of words. We have 4 separate workplaces with virtual reality hardware. First is passive stereoscopic projection system, then we have second structure with haptic manipulator and active stereoscopic projection. We have also haptic glove with 3D TV large screen and tracking room which is connected to head-mounted display device. Stereoscopic projection system is connected and integrated with tracking devices. Haptic manipulator with a large workspace is a solution from Sensible Phantom Premium 3.0, which is integrated with Sony 3D access. The third infrastructure, third system we have here is haptic manipulator with glove, and by using this haptic manipulator, first TNA access was done. Now I will talk about it in a while. And fourth one, is personal protection and tracking room. We have optical tracking system PPT X4, which is connected with magnetic wireless tracking system from Polhimo's Liberty Lightus, and we have gesture recognition gloves with wireless set. So let's back to TNA project. As I told you, we have conducted 2 visits. First one was in April, and Professor Darina Kumicakova from University of Žilina in Slovakia conduct a project called Exploration of the Robot Hand Grasping Abilities using Haptic Devices. And in June we have a second visitor. It was Dr. Ognian Uzanin from University of Novi Sad from Serbia, and he had done research under the subject application of hand gesture in virtual reality environment using 5DT Ultra Data Glove. Let's go back to the first TNA. The main goal of this TNA project was to obtain more information about robotic hand grasping abilities. In more details, guests from Slovakia provide some tests, the robotic hand grasping abilities by simulation with utilization of EON Studio virtual environment and our force feedback haptic device. The main challenges of this TNA project was to get familiar with virtual reality environment and the CyberForce haptic device, and to execute some experiment simulations of the test object. It was a cylinder of test object grasping, of course, and to execute additional experiments, some simulation of grasping of other of different shape were also done. The research plan during the stay at Poznań was conducted and divided into 3 phases. In the first phase, it was preparation of robotic hand and object models like cylinder, cube, and assembly part. For the simulations executed by the help of both the keyboard and the CyberForce device. So definition of rigid bodies were done, robotic hand as a kinematic body, grasped object as dynamic bodies affected by kinematic body, and environment as a static body. Then definition of the robotic hand self-collision detection was done, and also definition of the robotic hand and grasped object collision detection. which can be shown on the figure number 2, different color of the object. And of course setting of restrictions for movement for both second and third joints of the robotic hand was also done. These conditions were very important, and it was needed for more realistic simulation of the object grasping, and had to be improved gradually. So a lot of supporting experiment has to be executed. The second phase, it was a phase of simulation. So it was simulation of the cylinder grasping execution. To obtain more information about robotic hands grasping ability of objects of the cylinder type, the conditions were variable. So the cylinders of various dimensions were tested with a dimension of 40, 60, 80, 110 and 120 millimeters, and also different height of the data was tested. In first option it was 110 millimeters, and in second options it was 10 millimeters. And also various ways of their grasping were tried. Some simulations of the other object grasping were also executed. So the visitor have used the prism with a square cross section and with a height and with different heights, and also some assembly parts like shown on figure 5.1. A lot of these experiments were conducted. This is the picture of which have been made during the testing. As I told you earlier, the simulations were executed by the help of both keyboards in the first stage, and then with the cyber voice device. Of course, all results of the experiment were recorded in the form of text files and files of the simulation process screenshots. Description of the text file contained values of the finger every joint position, and it was recording during simulation and information about recognized contact. If the contact or collision were forecast, it was 1, and with no contact or no collision, it was 0. And simulation results help to obtain more information about robotic hand grasping abilities. The tested robotic hand is due to its kinematic suitable for a form closure grasping object most of all. Dimensional range for the cylindrical object grasping is from 40 to 110 millimeters. Grasping of prismatic object were limited by the cross-section. The cross-section was limited to 40 by 40 millimeters. And force closure grasping has many limits resulting from the kinematics of the robotic hand and the shape of the passive element of the robotic hand's palm. These results was very satisfied for the visitor. In fact, after the visit, Professor Kumyakowa decided to gather all the results which were conducted during her stay, and decided to write an article, and the article was published I think at the beginning of December, in the Journal of Manufacturing Technology. Professor Kumitsakova also sent me some utilization of obtained results for her further research. So she planned to continue this research to test the robotic hand grasping abilities in the simulation environment created in MSc Adams 212, which is established at her laboratory at the Department of Automated Production System of University of Żylina. So she would like to test the tending of the object form closure grasping to consideration of experimental obtaining limited minimum and maximum dimensions of objects of cylindrical or prismatic shape, and modification of the palm passive element for the solution of the task of object stable grasping. The second TNA, as I told you earlier, was Dr. Ognjen Uzanin from Serbia, from the University of Novi Sad. And the main goal of the project called application of hand gestures in virtual reality environment using 5GT14 Ultra Data Glove was to modify the previously developed by him probabilistic neural network based data glove hand gesture recognition system, which was trained and tested with 5 sensor data glove in order to allow it to work with the more advanced data glove with 40 sensors. Scientific challenges was to adapt the system's pre-processing stage to allow the PNN as the core of the gesture classification system to work with input vectors of higher dimensionality without significant deterioration of its performance in virtual reality environments. Once again, the scientific stay was divided to some research phases. At the first stage, it was the preparation of data acquisition program to allow collection of gesture data from various data gloves users and store them in data files named after the gesture designation. This is the picture of these gestures. Together 12 gestures of the gesture dictionary were used in this experiment. In the second phase, it was acquisition of gesture data for the 12 different gestures from the gesture dictionary. And in this experiment, 2 female and 3 male subjects took part. This acquisition process entailed following step. First, subject is first familiarized with the gestures and gets to try each of them before a real experiment. Then calibration was performed with fully opened hand and fully closed hand, after which the system was ready for operation. And in the third phase, subject was allowed 30 seconds to perform each of the gestures, during which time the system records the gestures as 10 member vectors, which correspond to 10 sensor signals. So 2 signals per each finger. In the third step, application of principal component analysis to reduce data dimensionality and allow the probabilistic network to perform gesture recognition on the data sets with reduce number of vector members. Example of the file which stored recorded gesture is in these pictures. As the result of the first stage of this investigation during the gesture acquisition process, each of the 5 subjects produce 12 data files. In total 60 files which need to be processed. So principal component analysis performed in the subsequent step of the processing, generated the PCA scores shown in this picture. And it was possible to see that for all of the subjects, all gestures could be efficiently reduced to vectors consisting of just serial numbers which represent the components which account for more than 90% of the variance. Some future work of this research, our visitor wants to train the PNN network using the reduced dimension dataset. He wants also to test the PNN for accuracy of gesture recognition, and of course provide some analysis of the results. I'm in contact with Dr. Uzanik, and I asked him for giving me some details about his future plans of this work, and he gave me information that currently he is in underwear of efforts to process and analyze the results of principal component analysis, which is the key to reducing the input data file that can be managed by the existing probabilistic neural network. Training and testing of the gesture recognition system will represent the final stage of the project. Also, based on this TNA, Dr. Luzanin decided to publish the results of his work, and I've just received information from him that his article was submitted to the Journal of Assembly Automation and is already available online. Here's the link of this paper. That's the short information about already made 2 TNAs.
I would like to have a question, if you allow me, about the 5DT analysis of the gestures and what you did with the data glove. Did you try to report the same thing with, you use the data glove as a sensor, but no, there are several systems which are able to detect the position of the fingers by video analysis or by infrared analysis with lip motion and things like that. Did you check if it was applicable to your system and if you can recognize with the API which are delivered by these systems, if you can recognize the gesture, because it would be very fine to enter in virtual reality room without gloves and without any equipment for the user?
Yes, we didn't do it in this project, but we have several, 2 or 3 another attempts. In these attempts, we in one PhD thesis, which is not ready now, but we made some research in video analysis of gestures. So we have very interesting results, and this work is in progress at the moment.